Hello, ladies and gentlemen. I'm hoping you guys had a good Thanksgiving because most of you are probably watching this afterwards, which is fine, as long as you get it done and back to me by Monday because we are starting Newton's second law on Monday because we are finished with Newton's first law. So, Newton's second law is a simple equation and it says if I have a net force, it's going to equal my mass times my acceleration. Now remember, Newton's first law is about, okay, what's happening when our forces are balanced? So when F net equals 0 newtons, which is what's going on in Newton's first law, then we know that the object is either at rest or it's moving in a constant straight line speed. So what happens when the forces are unbalanced? So when the forces are unbalanced, we have some acceleration. So we have F net, which remember we defined in class as sum of the forces. And usually it's a sum on the forces in the same plane. So remember, x's and y's are like Bloods and Crips, they don't mix. So I add and subtract all my x's and y's and add and subtract all my x's and all my y's separately. So M stands for mass, and that's measured in kilograms. And A is acceleration, and that is meters per second squared. So that is Newton's second law in a nutshell. And so here's the really, really important part about F net. F net is the sum of all the forces. So if I have a box that's sliding this way and I'm pushing it, I have some type of force called friction pulling the other way. So if I were to say what is the F net of this, the F net would be the force of my push minus the force of my friction, and that would still equal my mass times my acceleration. So now the equation gets a little more complex because that's what I want for the most part. Because I have a sum of the forces. So force net in this case would be my force of my push minus the force of the friction equals my mass times acceleration, which means if I have the force of the push and I have my mass and I have my acceleration, I can actually solve for my force of friction. So in your own words, describe the equation for Newton's second law. So that would be an unbalanced force causes mass to accelerate. So when I'm not moving in a constant straight line and when I'm not at rest, I have acceleration. That means, hey, I have an unbalanced force. So for example, we have a 15 Newton force pushing back, or pushing on a box. So let's call this our force push, and a 10 Newton force going on the back, which let's, for this case, just call it force of friction. We want to find the acceleration of the box. Well, we have F net equals my mass times acceleration, and we want to find A. So F net is really my force push minus my force of friction. It's minus because they're going in opposite directions, equals mass times acceleration. So now I just plug in and solve for the unknown. Force push is 15 minus 10 equals a mass of 10 times A. So 15 minus 10 is 5 equals 10A. Divide by 10. Divide by 10. I have A equaling 0.5 meters per second squared. So that's the acceleration of the box when these two forces are acting on it. Okay, so now you're flipping over to the back so we can fill out the back page and we'd be done. Anyways, so then on the back page I said, okay, now I have 100 newtons on pulling down. So this is my force due to gravity. And notice it's equal and opposite to my force normal. Force normal is a force perpendicular to the surface. And remember, force normal and force net are not the same thing. So find the acceleration of the box. Well, at this point, the forces are balanced on the x, and we don't are on the y, and we don't have any forces on the x. So the acceleration in this case is obviously 0 because of Newton's first law. The box is at rest. If the box is at rest, all forces are 0. And because we don't have a net force, we don't have an acceleration. We have a constant velocity. So just in review, remember that F net equals mass times acceleration, but F net is the sum of the forces. So I could have a force pull minus my force of friction, or I could have two forces pushing in opposite directions. I can even have two forces pushing in the same direction, but force of the pull minus my force of friction equals my mass times my acceleration. So that's one way we can find other forces. Just remember that force net is the sum of the forces acting on the box. As you can see, Newton's second law is pretty straightforward. It's only that equation. And let me show you something real quick. So what if we have constant velocity? So we have constant v, right? Well, if we have a constant v, we have no acceleration because the definition of acceleration is change in velocity. So because we have no v, a equals 0. So let's now plug it in to the equation. So my net force is my force push minus my force of friction. So no longer are we ignoring friction, equals m times 0. So I have force of push equals my force of friction equals 0. And so if I solve for force of push, I got to add the force of friction to the other side. Add force of friction to the other side, and I get my force of the push equals the force of the friction. And this lines up right with Newton's law, because Newton's law says, hey, if my forces are balanced, then I have constant velocity. So in this case, the forces are equal because they're balanced. So that's another way to find force of friction. So if you're ever moving at constant velocity and it says, hey, you're pushing with 10 newtons, what's your force of friction? Well, it's easy. It's just 10 newtons because they're equal and opposite. So once again, have a great Thanksgiving. Enjoy your 5-day weekend, and please be ready to work. Come back Monday because we are starting Newton's second law.